Hi everyone, welcome to Learn and Code. In the previous session, we have discussed about what would be the default values of an array. When an array is declared as global, then we discussed that the default values are zeros. Similarly, when the array is declared as static, then also the default values are zeros. But the thing is, when we declare an array within a function, means locally, then that is treated as automatic storage class and the default values are garbage values. After that, we have also implemented one program to find the sum of even numbers and also to find the sum of odd numbers in a given array that we have seen in the previous class. In today's session, we are going to discuss about multi-dimensional arrays. After that, we will see more number of programs. So let us go to multi-dimensional arrays. So under this, first we are going to discuss about two-dimensional arrays, or we call it as 2D arrays. After 2D arrays, we will discuss 3D arrays or three-dimensional arrays. So first we will discuss two-dimensional arrays. Before going to discuss two-dimensional arrays, so let us take an example of one-dimensional array. For example, here I am writing float marks of 50. So this is one dimensional array. Why? Because we have only one dimension. See, the array name marks is going to describe that there is a class of 50 students, right? We want to store the total marks of 50 students. Marks can be of type float, so that's why we have declared it as float marks of 50. But the thing is that I also decided that I want to store the marks of 5 subjects of a class. Not only total marks, I want to store the marks of 5 subjects. Each student is going to have 5 subjects. I want to store the marks corresponding to 5 subjects. In that case, what we are going to think that, for example, here I am writing float. You take S1 subject 1 of 50. This is for one subject, and another one is float S2. This is for the second subject, and float S3, this is for third subject, and float S4, this is for fourth subject, float S5, this is for fifth subject. So here we are going to store the subjects, 5 subjects marks of 50 students. But here, how many arrays we have to declare? S1, S2, S3, S4, S5, right? So this is a waste of time. So instead of taking like this, what you do is better to take an array, assume that better to take an array which is going to store 5 subjects marks, right? 5 subjects marks of how many students? 50 students. Here I am going to write two dimensions. This is the first dimension which describes the subjects, and second dimension describes the strength of the class. So here we are mentioning two sizes, or we can say two dimensions. So this is known as two-dimensional array. In this case, we need to declare an array of type float, and you gives any name like this float a of 550. So this is the two-dimensional array. So in this type of context, we need the concept of two-dimensional arrays. Let us discuss in detail what is the syntax of two-dimensional array. See, I'm writing the syntax here. The syntax of the two-dimensional array looks like this. As usual, you mention the data type. After mentioning the data type, here you mention array name, any name you can give. After this, you mention dimension 1, and second one is another dimension, dimension 2, and you keep semicolon. Dimension 1, dimension 2, or we can say size 1, and here it is size 2, right? We are mentioning two dimensions, so that's why it is called two-dimensional array. Okay, example, I'm giving one example. You can take any array, the data type could be anything, integer a, here mentioning 5, and second one is 3. This is one kind of two-dimensional array. Float, B, 3, 2, any kind of array you can also take. And character, C, 5 and 4. These are the different types of two-dimensional arrays. When we say A of 5, 3, then it is going to contain 5 into 3 elements. That means 15 elements. Means 15 locations are reserved. 15 locations are reserved, and how much memory is allocated? 15 into integer takes how many bytes? It may take 4 bytes or 2 bytes. If it takes 4 bytes, 15 into 4, how much? 60 bytes of information is allocated or reserved for an array A. In this context of B of type float, right? 3 into 2, total how many locations are reserved? 6 locations into float takes 4 bytes. How much amount of memory is allocated here? 24 bytes of memory. So for character, how many characters we are going to store? 5 4 ja 20. You just multiply the dimensions. 5 4 ja 20. 20 locations are reserved, and each location is going to occupy one character. So the amount of memory is allocated as 20 into 1. How much? 20 bytes of memory. This is the memory allocation for the two-dimensional arrays. So we will see how the memory will be represented, or what is the memory representation of two-dimensional array. Here I am talking about memory representation of two-dimensional array. See here, actually two-dimensional array is nothing but the array of one-dimensional arrays. When we discuss the concept of multi-dimensional arrays, please remember that it is an array of arrays. Array of arrays. So if you want to see the memory representation of two-dimensional array, for the following example, here I am taking integer a of 3 and 2. Whenever we say int a of 3, 2, totally 24 bytes of memory is allocated. How? 3 2 ja how much? 6 6 4 ja 24 bytes. So here I am drawing the memory representation here. First, how to write this memory representation? If you observe the first dimension, carefully observe the first dimension. What is the first dimension? 3. First, you divide this total memory partition into 3. Why? Because the first dimension is 3, right? After dividing into 3, you name it the first memory location as A of 0. 3 means size, right? 3 means size. Size indicates 3 memory locations. First memory location, just I'm writing A of 0, and second one is A of 1, and third one is A of 2. I'm talking about only the first dimension. Now, see, in single A of 0, now you go to the second dimension, how much? 2. Means in the first block, again we are dividing the first block into two partitions, 2. In the second part also, again make 2 partitions here. For the last part also, you make the 2 partitions here, right? Now this is the first one, and this is the second one, and this is third one. See, first dimension 3 indicates this is the first part, second part, and third part. This is about the first dimension. Now, in each part, you have to store how many elements? 2 elements. Means how many locations you can divide? 2 locations. That is the first one and second one. See, this is the first location of A of 0, that is indicated by A of 0 0. This is the second location of A of 0, that is represented by A of 0 1. Very, very important. Now, this is the first location of A of 1, that is indicated as A of 1 0. This is the second location of A of 1, that is designated as A of 1 1. Now, coming to this is the first location of A of 2. First means you represent as 0, and this is the second location of A of 2, that is called A of 2, we call it as 1. This is the naming that is done to the two-dimensional array. So this is A of 0 0, and this is A of 0 1, and this is A of 1 0, this is A of 1 2, A of 1 0 1 1, sorry, not 1 2 1 1, and this is A of 2 0 and this is A of 2 1. So in diagrammatical representation, I can say one thing, that whenever we declare A of 3 2, its meaning is A of 3 2. You do one thing. First, take this as a root, divide it into three parts. This root means array. Array A is divided into three parts. First dimension I'm talking about. So you write it as A of 0, second A of 1, and last one A of 2. Now after completing this dimension, go to second dimension 2. Now each one means A of 0 is divided into how much? Two parts. This is again divided into two parts. Again last one also divided into two parts. Here it is. This is the first part of A of 0, that is denoted as A of 0 0. Okay. This is the second part. Second means 1. A of 1 of A of 0. We call it as A of 0 1. So here this is the first part of A of 1. That means you say A of 1 0. This is second part of A of 1, that we call A of 1 1. And here it is A of 2 0, and this is last one is A of 2 1. This is the memory representation. I think it is understood. This is the memory representation of two-dimensional array. Now after this, how to initialize a two-dimensional array? Two-dimensional array representation. Array initialization. Initialization. So in this initialization part, for example, if I say integer A of 3 and 2, how to initialize this? Just you write here opening brace and here closing brace. So in this, there are how many? What is the first dimension? 3. Okay, you write 3. You write 3. Okay, I'm mentioning 3. Right? In the in the first, this is the first part of 3, second part of 3, and third part of 3. Again, each part is divided into how many elements? 2 elements. Means 1 comma 2. Okay, 2 elements. 2 elements. Second part also 2 elements. Any elements you can need 3, 4, 5, 6. Like this you can initialize. Or directly what you can do, as one dimensional array, you can say integer A of 3 2 is equals to, just you can say 1 2 3 4 5 6. Like this also you can say. So automatically they are divided into like this. These are the two possibilities by which we can initialize a two-dimensional array. How to read the element? This is the what is the initialization. How to read the elements into two-dimensional array? So when we want to read the elements into one-dimensional array from the keyboard, we have used one for loop, right? When we have two dimensions, you have to use two for loops, right? Why? Because we have two dimensions. Now coming to three-dimensional array, just I'm writing three-dimensional array. What is the syntax for representing the three-dimensional array? Same as previous one, just you mention the data type. After that, array name, any name you can add. See here, I'm going to mention three dimensions. So this is dimension 1, dimension 2, dimension 3, three dimensions. For example, I'm writing like this, integer A of 3, 2 of 4. In this case, what happened? You multiply all the dimensions, 3 into 2 into 4. Total how much? 24 memory locations are reserved. And each location is going to take 4 bytes. That means 4 4 is 6, 16, 1 4 to 96. Totally 96 bytes of memory is allocated for this integer array. In this case, what you do is A of 3 to 4. It indicates that if you take the first dimension separate, it indicates that there are three two-dimensional arrays. The meaning of this is there are three two-dimensional arrays. The concept of 3D array is nothing but it is array of two-dimensional arrays. Three-dimensional array is an array of two-dimensional array. Two-dimensional array is an array of one-dimensional array. That you carefully listen. So, how to represent the memory or how to refer to the memory locations by using subscripts or index? See, in one-dimensional array, the first index is given as a of 0. We call it as this part as subscript, or we call it as index. If you take two-dimensional array, the first index is denoted by a of 0, 0, right? This is the way to access the elements, or this is the subscripts which we have to use for two-dimensional arrays. So when you talk about three-dimensional arrays, we have to mention three subscripts like this. This is about the three-dimensional arrays. So if you want to read the elements into three-dimensional array, again we need loops. But how many loops? Three loops. As the dimensions increases, the number of loops also increases. How many loops you have to use to read the elements into two multi-dimensional array depends on the dimensions. How many number of dimensions are there? Now, what is the memory representation? How to represent the memory? So similarly, for example, if I say integer a of 3 to 2, small example I'm writing. So how it could be represented in the memory? So like I said, first take an array root. First take the first dimension. How much? 3. Now you divide into 3. Okay. So we call it as assume. First I'm taking only dimension, first dimension. We call it as a of 0, and second one is a of 1, and last one is a of 2. All right. 3. Now after that, each one is divided into 2. Take the second dimension, right? 2, 2, 2. Now after that, take the last dimension. Again, it is divided into 2. Okay. But before moving on to 2, what you do is this 2 indicates that this is first of a of 0. First of a of 0 means we call it as a of 0, 0. This is what you say second of a of 0. Second means 1. Why? Because the counting of elements in an array starts with 0. This is second of a of 0. First you mention a of 0, second means 1. This is first of a of 1. A of 1. Who's first? A of 1. A of 1, 0. Now this is the second of A of 1 means second means A of 1. This is A of first of A of 2. That means we call it as A of 2, 0. And this is second of A of 2. Means first you mention first subscript A of 2 and second one is 1. This is the way of denoting. Now you take the last subscript 2. Now each again divided into 2. This is I'm drawing for understanding purpose. See here, this is first of A of 0, 0. First of A of 0, 0 means we call it as you write as it is the root A of 0, 0. First 2 means 0. This is again A of 0, 0. This is second, right? Like this. So this is a way of denoting the elements. This is the memory representation, and totally there are how many? 3 to just 6, 6 to 12 locations are there. 12 locations are represented like this. First location is A of 0, 0. Next we have 0, 0, 1. Here it is A of 0, 1, 0. This is A of 0, 1, 1. Like that it is represented. So in more details, we will see in the programming part. So just now we have seen how to declare two-dimensional array and what are the subscript that we have to use to refer to two-dimensional array memory locations. And also we have seen how to declare the three-dimensional array and what are the subscripts or the indexes that are used to refer to those elements. And also we have seen how to initialize two-dimensional array. And more examples we are going to see by using Visual Studio Code. So let us go to Visual Studio Code to implement two-dimensional arrays first. Now we will see simple program to implement two-dimensional arrays. So let us go to Visual Studio Code and go to new file and you write 2D two-dimensional arrays 2D dot I'm writing C dot C. Here I'm going to write comments hash double hash I'm writing in a program to implement 2D array. Just I'm writing 2D array. Okay. Now you know first statement is hash include stdio dot h, next int main. Okay, now here you have to declare an array, hash include stdio dot h. Right here, in after opening brace you have to declare an array. So it may be integer array or character array or float array, any array. I'm taking integer array, and you take any name, a, or you can say array. Arr means array. So what is the dimension? First dimension I'm mentioning 5, and second dimension I'm mentioning 3, right? So this is two-dimensional array declaration, 2D array declaration. We call it as the declaration. See, whenever we say integer array of 5, 3, total number of locations reserved 5 into 3. 5 3 is 15. If an integer takes 4 bytes, 15 into 4, how much? 5, 15 4 just 60. 60 bytes of memory is allocated for an array. Already memory reserved. Total 15 locations, but the amount of memory allocated is 60 bytes. Right. So, how many loops we require? Two loops, right? Because two dimensions we have referred. So two loops are required. For that, there is a need to declare two variables integer I and j. One variable is for first for loop to represent the first dimension, and second variable j is to represent the second dimension, right? ij. Now, what we are going to do is we are going to read the 15 elements, right? So you say printf enter the elements into. I'm writing 2D array. Just you write 2D array slash n double quotes close, and last one is this. Enter the elements into two dimension. Now read. How to read? Again, you use first for I equals to 0 and I is less than 5. So 0 to 4 means total 5. That is the first dimension. I plus plus. Okay. I plus plus. Now second for loop you write for j equals to 0, and what you say is j equals to 0. Now you mention j is less than, what is the dimension? 3. J is less than 3. Yes. Now after that semicolon you write j plus plus. This is second for loop. Now you write scanf percentage d double quotes close comma ampersand a of ij. This is the way to read the elements into two-dimensional array. Right after this, if you want to print the same elements, just after reading, what you do is just copy the same code and you write here, paste it, but instead of scanf, just you write printf percentage d, and don't write ampersand. Why? Because it prints addresses, but we want only the values. Last statement we write is return 0. This is a simple program to read the elements and to print those elements. While printing, we want some space. Instead of writing only percentage d, you write slash t after percentage d to get the space. Now you save it. Now you run it. Some error is there. What is the error? The program we are taking is return 0 stdio.h hash include. Now I'm going to copy it. Okay, right. Some error is there. Okay. So here we said A, right? A, not A, ARR, right? ARR. Here also ARR array. Right, that is a mistake we have done. Right. Now save it. Now you again run it. Okay. Now it is asking enter the elements into 2D array. You give any elements. I'm writing 1, 2, 3, 4. Total how many elements? 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? 15 elements we have entered. And we have printing all these elements right here. See, it is printing in a single line. So instead of using slash t, better to use slash n. So that they are going to print line by line. That is also valid. Better to print the values in line by line, right? See, again run, enter the elements into two-dimensional array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Instead of giving the values in sequence, you can give in any order. See, I have given the elements 15. Again, I have printed 15 elements. So this is a simple program to read the elements into two-dimensional array and print those elements. That's all. So I will explain the execution part. So 5 3 means 15 locations are reserved, right? Okay, it is asking enter the elements into two-dimensional array. Now first what happened, I equals to 0. First this part is executed, I equals to 0. Now 0 is less than 5. First this condition is tested. Okay, condition is true. When the condition is true, then it goes to the second for. In the second for, j value becomes 0. Now 0 is less than 3. Yes, the condition is true. First for loop is true and second for loop is true. First we have initialized I equals to 0. 0 is less than 5. The condition is true. When the condition is true, we have went for the second for loop, j equals to 0 and 0 is less than 3. Yes, the condition is true. When this condition is true, this scanf statement is executed. What the scanf statement is going to do, it is going to read the elements, or it is waiting for the element to be entered from the keyboard. See, we have pressed 1, right? So that 1 is read into array of 0 0. What is I value? 0. J value also 0, right? The first element is read into the address of a of 0 0. Okay, now here semicolon is there. See, the important point here is the semicolon sends the control from upper for. What is upper for? There are two upper fors, right? But first it sends the control to the second for. See, though you don't have any opening braces and closing braces, when we use two for loops and one scanf, see the last scanf, this scanf comes under two for loops. See what happened, this semicolon sends, I will keep opening brace and semicolon, but if there is no opening brace and closing brace, what happens? This semicolon sends the control to whom? This j plus plus. Now j value becomes how much? 1. Now the condition is tested. 1 is less than 3? Yes. Now it is going to read the second value, that is 2, into I value already how much previously? 0, and j value how much? 1. So 0 1. Second value is read into 0 1. Next j value becomes 2. 2 is less than 3. Yes. Third element read to 0 2. Okay. Now j value becomes 3. 3 is less than 3. No, condition is false. In this case, what happened? When the condition is false, here we think that the scanf statement is not executed and we are going for this for. No. When this condition is false, when 3 is less than 3, what happened? This semicolon sends the control to upper for this I plus plus. That is the logic. To understand clear what we do, here you write opening brace and here we write closing brace. Right? Here also we write opening brace here. For clear understanding, here you write closing brace. Though you don't write this opening brace and closing brace here, same meaning. But for clarity, I have written opening brace here. Now, I value becomes 1. 1 is less than 5. Yes. When the condition is true, again it is entered into the second for loop. Again, it starts with j equals to 0. Again, the condition is tested. Like that, first the inner loop is repeated. If I equals to 0 first time, then j is repeated 3 times. For j equals 0, j equals to 1, j equals to 2. Next I value becomes 1. For I equals to 1, again it is repeated 3 times, 0, 1, 2. So like that the elements, 15 elements are read and the same elements are printed by using the last two for loops. This is a simple execution of the program to read the elements into two-dimensional array and printing those elements. So in the next class, we will see the programs, more programs using two-dimensional array. With this, I am going to close the session. Thank you for watching.